Hello again. We are ready to get into our second part of number sense here in preparation for the CSET. And this section we're talking about our number line and how the number line represents our number system. And basically the number line actually represents the real number system. And we'll talk a little bit more about that later, but it is called the real number system. What people need to understand about math is that math is a science. It fits under a science, and every science class you've ever had, biology, chemistry, whatever you've had, it always has a vocabulary in that, and you need to know the vocabulary terms. And math is a science just like that. And so there are lots of vocabulary terms that you need to know within math. And so we're going to have several vocabulary terms here. And so either you need to write these terms down, or you need to look at the written part in Moodle for this section of the course to be able to see some of this. But whatever you need to do to make sure that you catch these terms. So the first term that we're going to talk about here is an integer. You need to know what an integer is. And so an integer, an easy definition of an integer is typically the numbers that are represented on a number line are the integers. But we need to be a little bit more specific than that. And so the integers actually end up causing us to go into other vocabulary terms. And so the integers end up making us go to the whole numbers. And so there's another vocabulary term, whole numbers. The whole numbers are the counting numbers, which is what we talked about in the last section of Adam going around and counting the animals and so on. The numbers we usually use to count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those numbers plus the number 0 is what makes the whole numbers. Okay? And so when we talk about the whole numbers being 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the integers encompass those numbers as well as the negative whole numbers, okay, or the negative counting numbers, sorry. And so the integers are represented typically on a number line. That's the easiest definition maybe of integers. And so the integers represent negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, continuing on in each direction. Those are the integers. They are whole numbers. We're not talking about any parts here, any fractions or decimals or anything like that. We're talking about whole numbers, but we're also talking about negative whole numbers, okay, and the number 0. Those are all represented by the set of numbers called the integers, okay. The set of integers is infinite. All these sets of numbers that we're going to be talking about are all infinite, because as you continue to count in either direction, there's always one more number beyond that, okay. And so integers are represented within our number line. And so this is a typical number line. This is the number line that you normally see in textbooks, in classrooms sometimes with the little posters that can be put up and so on. And so this is a typical number line the way that it's drawn. But you know, I want to change this a little bit. I want to look at this a little differently. And so we're gonna get rid of this number line, and we are going to go and draw this number line just a little differently here. Okay, I'm going to draw this number line this way instead. Okay, I'm going to draw it vertically to where 0 is in the center. Okay, this is negative 1, negative 2, negative 3, negative 4, negative 5, and so on. Okay, this is a positive 1, positive 2, positive 3, positive 4, positive 5, and we continue on forever. Okay, now you don't normally see the number line drawn this way, but this is the way we want to look at it for our examples that we're talking about. And one of the reasons why we want to look at it this way is because I believe it makes things a little bit clearer. And so, again, looking at some life experience here, the negative numbers down here, well, we're used to things this way a little bit more. So maybe like a thermometer when we're looking at the temperature outside or whatever. We see a scale like this instead of a scale horizontally. And so if it's a negative 5 degrees outside, that just makes more sense to us because that negative 5 is 5 degrees below 0. And that's the way we refer to it, below 0. So negative numbers are numbers that are less than 0. So they're below 0 or they are to the left of 0 on the normal number line. Okay? And so we can refer to that as temperature is a common example where that might make sense. We can think about this maybe as money, although that's maybe not a good example, but hopefully we're not overdrawn in our checking account too often to we're in the negative numbers. But we know that, you know, if we're running a a budget or whatever, maybe we're in the hole a certain amount of money for the month or for the week or whatever the time period may be. And so we can look at it in that way, okay? And what you need to understand here is that that concept also, because you're further, like negative 20 degrees is colder outside than a negative 2 degrees. And so because negative 20 is further down the scale, negative 20 is a smaller number than negative 2. Okay? Even though the digit itself may look like it's bigger because it's 20 compared to 2, but because it's negative, it's further down, and so negative 20 is colder than negative 2. Or another example is if you're overdrawn in your checking account by $90, that's worse than being overdrawn in your account by $3, right? And so that further down the scale is a smaller and smaller number, okay? So having this sense of order within the number line is a critical concept on the CSAT. There will be questions that ask you specifically to just put a set of integers in order. And you have to be careful with the way the question is worded, because the question may say put them in order from least to greatest or from greatest to least. Now typically I believe they will say from least to greatest. So an example of that might be something like this. If they ask you to put these numbers in order, okay, then we need to think about that number line concept. And again, if the question says numbered in order from least to greatest, then we need to find what would be the coldest temperature, what would be the worst overdrawn situation in our checking account. We need to find the smallest number here first. Well, the smallest number is the largest digit with a negative in front of it, right? Because that makes it further down the number line. So the smallest number here is negative 15. Let me try that again. The smallest number is a negative 15. Okay? Then we need to go to the next bigger negative number. And so as we progress up the scale in temperature or up the scale on the negative side, we would get to negative 6. That's the next biggest number here. So negative 6 would go next. Negative 3 is our only other negative number, and it is bigger than negative 6 because negative 3 degrees is not as cold as negative 6 degrees. Okay? Or is warmer if you want to put it that way. Our smallest positive number here is 2. Next smallest positive number, or the next bigger number, is 4. And the largest number in this entire list is 12. So this is the smallest number, this is the largest number, and we have put them in order as they would go on a number line. And so those are common. That's a common question on the CSAT in this particular section, is being able to put a list of positive and negative numbers in order from least to greatest, or sometimes from greatest to least. Okay? All right. Our next vocabulary term is something that you've probably heard and maybe been confused about. I don't know. Hopefully we can explain it in a new way to you today. And that other next term is absolute value. So you need to have an understanding of absolute value. The absolute value of a number. Okay? And it comes back to our our number line concept here. And so just what we were talking about, how much further down is negative 20 compared to negative 2? Well, that has to do with absolute value. Okay? That distance of how far it is away from 0 is a concept of absolute value. Okay? So we want to think about absolute value as the distance from 0. And maybe you haven't heard of it this way before, but that's what the absolute value is. It's how far a number is from 0. Okay? And we're talking about vocabulary in math, but notation in math is extremely important also. It's kind of like the vocabulary. It goes right along with it. Notation is part of the vocabulary. And so the way we notate absolute value is 2 vertical lines on either side of the number. And so if we're talking about the absolute value of 5, well, if we take it to this example that we're talking about, how far is 5 from 0? It's 5 units on the number line from 0. So the absolute value of 5 is 5, because that's how far 5 is from 0. Okay? What if we wanted the absolute value of -4? Well, how far is -4 from 0 on the number line? -4 is 4 units away, 4 units below 0. And so the absolute value of -4 is 4. So sometimes maybe you've heard absolute value defined to be that it's always positive. You just take the positive of the number. And that's an okay definition, but I think this just makes a little bit more sense. Okay? Because sometimes they can throw in some signs in here and so on that can throw you off on this. So you need to be careful with absolute value, and I think going back to this definition just makes it a little bit clearer. So whatever the number is in here, however far that is from 0, that's the absolute value of that number. Okay? And so there will be absolute value questions on the CSAT as well. All right? Okay, going back to our number line, you need to understand that just integers, that's not all that's represented on a number line. We can find any number in the real number system on the number line. Okay? And so what I mean by that is, let's go ahead and go back to our traditional number line, I guess. And so on our typical number line, we can find numbers in here, even though they're not necessarily notated yet, but we can find numbers in here like fractions. Okay? And so if we want to find the fraction, let's say 1.5, well, we can find that on here. Okay? We can find 1.5 being halfway between 1 and 2. And so right there is 1 1/2. Okay? We can find numbers like decimals on here. And so let's even go maybe in a different direction here. So let's say that we wanted to find a -0.75. And so if we wanted to find a -3/4 or -0.75, we could go right here and find a -0.75. All right? Or let's say that we wanted, let's say the number pi. Can we graph the number pi on a number line? Well, sure we can. An estimate of pi is about 3.14, so that, again, there's a decimal. And so we could graph pi being about right there. 3.14, okay, is approximately 3.14. That's pi. Now, this whole concept of what I'm doing here on the number line gets us into another set of vocabulary terms where we need to understand that this dot that I'm making is called the graph. And so I am graphing numbers right now. So the dot is the graph of the number, okay? And the number itself, the 1.5, the 0.75, the pi, the 3.14, whatever number it is, the number that we're using, that I'm labeling it with, the number label here, is called the coordinate. So we have the dot, or the graph of the number, and then the coordinate that goes along with it, it tells us where that dot is. So the coordinate is the number, the dot is the graph. Okay, so it may ask you graph -3, or it may have a number line here with a dot somewhere on it. Say maybe there's a dot right there, and it'll ask you what is the coordinate that matches that dot. And so you would say 0 for that case. Okay, so you need to know those two terms and how they differ from each other. Okay, the graph and the coordinate, how those are different. All right. This takes us actually into a few more. So we can represent any number on the number line. That's what you need to make sure that you catch. And again, it's infinite. And so we can get infinitesimally small here between. We can go down to 0.5, 0.4, 0.3, 0.2. We can go to 0.25. We can go to 0.251. We can represent any number on the number line as a graph. Right? Any number can be written there. Okay? Don't think it just has to be the integers, because those are the only numbers represented typically on a number line. Any number in our real number system. Okay? This kind of takes us in terms of preparing for the CSAT, it takes us into a kind of another little branch of vocabulary here that you need to make sure that you understand. And we need two terms here. One is called prime. And again, this is probably a term you've heard over and over and over again as you were coming up through math. But a prime number is any number that can be only divided by 1 and itself. Okay? So, for example, the number 5. only 1 and 5 go into 5, okay? Or the number 13. Only 1 and 13 go into 13, compared to, say, 12. 12 is not prime because 2 goes into 12, 3 goes into 12, 4 goes into 12, 6 goes into 12. There's lots of numbers that go into 12 that will divide into it, okay? But a prime number like 17, only 1 and 17 go into 17. So automatically, the prime number, okay, now we have to be a little bit more specific here. Prime numbers are any numbers greater than 1 that have as divisors only 1 in itself, okay? So 2 is actually the only even prime number because 2 is greater than 1, but the only numbers that go into 2 are 1 and 2, 1 in itself. So 2 is defined to be prime. However, any other even number, 4, 6, 8, 10, 12, 14, any other even number is not prime because by definition an even number means 2 will divide into it. So the only prime numbers can be odd, okay, but not every odd number is like 9 is odd, but 3 goes into 9. So not every odd number is prime, okay, but only odd numbers can be prime. And so as you look at the set of numbers, now again, this concept of prime numbers, we think of it as being somewhat limited, okay, 2, 3, 5, 7, 11, 13, 17, 19, so on. Only a limited set, but yet it's still infinite. It is still infinitely large because whatever prime number we find, we can find another one beyond it. Okay? So prime numbers are any number larger than 1 with divisors only of 1 in itself. Okay? Now, kind of the opposite of a prime is called a composite number. And the CSET may use that term, asking you for a composite number. A composite number is one that's not prime. A composite number has other divisors besides 1 in itself. So these are kind of opposites of each other. All right? Okay, now we've used this term infinite a couple times already. I've used it. In the number line represents an infinite set of numbers. There's an infinite number of prime numbers. You know, all these number systems that we're talking about, they're all infinite. Okay? Well, the concept of infinity has eluded man and has intrigued man ever since Adam started counting the animals. And some mathematicians specifically have just spent their lifetimes researching and studying the concept of infinity. And so this concept of infinity is something that you need to make sure you have a basic understanding of. And so when we talk about an infinite set, or the concept of infinity, okay, means that it is uncountable. Means that no matter what number we get to, there's always one more number. Whatever number I count to, I can always count one more. Whatever number I go down on the scale to, there's always one more number beyond that. And so that concept of infinity, and the symbol, again, notation for infinity, is a kind of a sideways 8. It's called a lemniscate, okay, or a lemniscus. That symbol there represents infinity. And so you just need to be familiar with that symbol because some of the answer choices on the CSET will have that symbol there to represent infinity. All right. I've also used a vocabulary term here that I haven't really defined, the real number system. We talked about the number line representing the real number system. And so the real number system is, until you get to a level of math that is at least Algebra 2 or higher, you don't hear about anything outside the real number system. Okay, but there is something outside of the real number system, and it's not fake numbers. They're actually called imaginary numbers. But the number line represents real numbers. And so you need to have an understanding of that concept, that the real, what the real numbers include. The CSET expects you to know that. And so the real number system includes all the positive numbers, all the negative numbers, okay, positive fractions, positive decimals, positive whole numbers, negative fractions, negative decimals, so on, okay. It includes fractions, as long as those are normal fractions, okay, and it includes decimals, It also includes numbers that are called irrational. And here's another vocabulary term that you should know. An irrational number is any number that cannot be written as a fraction of integers. So like 1/3, that's a rational number because it can be written as a fraction of 1/3, which are both integers, and so that's a rational number, it's called. Part of the word rational is ratio, and a ratio is a fraction. And so 1/3, 2/3, numbers like that, fractions like that, are rational numbers, but numbers that can't be written as a fraction. For example, the number pi. The number pi, even though in elementary school we use 22/7, that's a very bad approximation of pi, that's not exactly pi. And so pi is an irrational number. So pi is an example of this. Any square root that is not a perfect square root. So for example, the square root of 5. Square root of 4 is 2, but the square root of 5 is not a fraction even, not a decimal, not, it goes on forever as a decimal. And so the square root of 5 is called an irrational number because as its decimal representation, it goes on forever. It never terminates, never stops, okay? And it has no pattern of repeating to it. And so even though like a number like 1/3, when we write it as a decimal, is 0.3333333, okay? So because there's that pattern of repeating and because it can be written as 1/3, that's a rational number. But a fraction that can't be written that way is called an irrational number. Okay? And there are other, any radical that can't be written, any square root that can't be written that way, or any other cube that can't be written to where it comes out to an even number is called an irrational number. Okay? Okay, so in the written materials for this section of the course in the Moodle environment, there is a diagram that it would probably be good that you looked at, but we'll go ahead and try to replicate it here. I'm going to draw it a little differently than it is in the materials in the book because that was something that was represented on a Google search and so on, and that you could find. I'm going to represent it just a little bit differently here. Okay, but we want to look at a diagram of the real number system. Okay, and I'm gonna do it in the written material. It's done with some ovals. I'm going to do it with a rectangle here, and so we're going to split the real number system. Okay, so this represents the real numbers. Okay, I'm going to split this basically in half, but again, that whole concept of infinity here needs to progress through all of this because every one of these sets is infinite. Okay, so our box here is an infinite box. There are an infinite number of real numbers inside here. Okay, but on one side of this, we're gonna call this the rational numbers. On the other side, we're going to call it irrational. The irrational numbers. So the rational numbers are numbers that can be written as a fraction. They are numbers that can be written as a ratio, as long as those numbers on top and bottom of that fraction are integers. Okay? Irrational numbers are numbers like pi, square root of 5, square root of 7, even the square root of 6. Any number that doesn't come out evenly. Square root of 10 is a decimal. There is another number kind of like pi called e, and there's other numbers that fit into the irrational numbers that kind of get a little bit more complex. Okay, but we need to know this set exists. Okay, rational numbers break up into several other sets. Okay, one of the biggest sets within rational numbers is integers. Okay, within the integers, again, are whole numbers. Okay, positive and negative whole numbers. Okay, outside of that would be things that are out here would be things that can't be written as an integer, like 1/10, or like 0.25, or numbers that are fractions or decimals that don't apply to this. This could be 1 3/4 out here. Okay, so fractions and decimals are rational numbers, but they don't fit inside of integers because the integers have to be whole numbers. And so within this set of integers are the whole numbers that we talked about. Okay, and so the whole numbers are just that, whole things. Okay. And so the whole numbers would be things like, well, let's look at the set within this. The set within this is the counting numbers. And that's where we started with our first video, right? First section. The counting numbers are 1, 2, 3, 4, 5, and so on. Counting things. The only thing outside of that that still sits inside the whole numbers is 0, 1, 2, 3, 4, 5, and so on. The only thing that sits outside of that set inside of the integers are the negative whole numbers. And so the integers are -5, -4, -3, -2, -1, 0, 1, 2, 3, and so on. Okay? The integers just include negative whole numbers. The whole numbers include the counting numbers plus 0. Okay? So you need to have a concept of our real number system within this set. And again, a better diagram than my handwriting is within the printed materials of this section inside the Moodle environment, and you may want to go look at that. My only other thing that I have here is that there is a great app. If you have an iPhone or an iPad, I'm not sure if this is available on the Android market or not, but it is simply called Numberline. And there's a Numberline app, and if you happen to be a number person, then this can be pretty addicting. And it's the Numberline, and it has to do with the type of question I was saying that I gave you an example of. The CSAT will ask you, put these numbers in order. Well, that's what it's doing. It's just that on the iPad or iPhone, of course, you're touching it and you're just dragging it where you want it to be. But they'll give you a set of, I believe it's like 6 numbers, and ask you to put those in order. And those numbers are fractions and decimals and whole numbers and so on, and you have to compare them and then drag them to the number line in order, and of course it'll tell you whether you're right or wrong. It's a great little app. It's free, and so go to the iTunes store and look for Numberline. And I haven't searched it recently, so I don't know. There may be other number lines out there, but this one app called Numberline is a great free tool. And I have a link for it for you in the printed materials within Moodle, the written materials in Moodle for that app. It's a great app, great fun to play. It's great for your kids to play. Yeah, if you are an elementary teacher in a classroom and have access to iPads and so on within your classroom, it's an awesome app for your kids to play. So check that out. All right, we'll see you in the next section. Thanks.